Good evening, good afternoon, good morning, everybody. Welcome on back to the Dragons Den. Digital Dragon, 3D printing variety streamer here on Twitch. I think most of you guys already know that. How's it going, guys? Guys, gals. Everybody's having a good day. It is a Friday, so that is a beautiful day of the week because that means hopefully you're starting your weekend, work's over with. I don't know, KB3D Chris may be still trying to ship things, who knows. But I just wanted to reach out and say hey to everybody. Like I said, we had a rainstorm that came through that kind of very loud and wet for a while, so can't run the lawnmower without digging ruts in my yard because I have a big zero turn. So I get a hall pass from yard work. Cool as oh, that's right. I remember Evil Diesel came over earlier today to pick up some extrusions. He said it was his last day of school for his daughter. So, awesome. So today we've got the Don't Tread on Me, or actually I think it's Coffee or Die, which is still Don't Tread on Me, and Black Rifle Coffee Company up. This is about as much as my standard Yeti mugs, and we're on full test right now on this cup. This is the Hack to Squatch Dark Roast. So not over forever, just for the week. Well, I mean, school year is, I don't know. First school year is weird. It's weird. So anyhow, we got some coffee. We got a free stream for the week. So now we're just going to try and close out a couple of items that we had left over from last night and keep going on the build. Still working on the frame and the Z-axis. Sorry, folks. Last night, I did take the frame downstairs, put it on the kitchen counter, and just make sure that things are squared. So we got rid of a lot of the wobble out of it. So that was good. I also ran out of my brackets. So I don't know. I ordered another set so we have enough that we can do every conceivable corner possible that we can do without running into an issue. The got some more parts printed, as you can see here in the middle. We got some, I think I'm going to do a good portion of the enclosure frame parts and the nanotube gray, like this, which will be the door latches and stuff. But I think like the corner and the side brackets that hold on the panels, I may do in the lime green just for contrast. We'll see. I'm still trying to decipher some of the files. This is really weird. Like normally on a Voron, it says, boom, here's your base, go print all this. And really the only things where you have differences are in the tool head, and it's really the big difference is which hot end am I doing, because I'll have a different like tool head piece there for self burner, and am I going to put a NAMI in it? I mean, yeah, there's some changes of, oh, I'm going to run this extruder or that extruder, but that gets you into the, you're now, I'll say, out of bounds of a standard, difference. Here, it's like, well, you can use these latches or you can use those latches. You can do this or you can do that, or you've got like 3 different cameras, 2 different screen mounts, and it's just trying to decipher what I need when is going to be a little difficult. So bear with me as we go through this build. We may very much be making ad hoc decisions on the fly. Welcome along for a ride. This is going to be a ride. I did get some of our tools done. So I just printed these out in white PLA. And these are going to fit right here and will allow us to set this gap appropriately on both sides. And as you can tell, it won't fit there. You need to make some adjustments. What I'm going to do is flip this over. And then I'm going to loosen our line joints on either side. Get the right driver in it. So we're just going to loosen these a tad bit on each side. Like that. Then we'll be able to slide this in on each side. One there, one here. Now, get it in on each side. Kind of hold it down to where it's nice and tight on. Should not be this difficult. Okay, here we go. Now we're going to tighten this up. I want to make sure that I'm sandwiched so that this rail doesn't go one way or the other. So I'm going to grab my 1, 2, 3 blocks, kind of sandwich it as we tighten this side up. Same thing on the far side. 1, 2, 3 blocks. Get together. Get our bracket there. Bring things down nice and tight. Hey, Shenanigans, how's it going, my friend? Hope you're doing well. I don't feel like that's laying in there right. So maybe I will lay this way. Use our favorite phrase and say we're going to use gravity as our friend. Because it just feels like this side is still a little loose. So we'll use gravity as our friend. Push it tight. Use our 1, 2, 3 block to make sure that it stays nice and level. Tighten it up. Hey, Pez, how's it going? Hope you are doing well. I don't like that so loose on this end. Better. Because once again, we're doing this in order to make sure that these are at the same height and fully parallel so that we don't have any issues down the road. Made it in for a bit? Well, good. Good, good. How's it going, Shenanigans? That up, loosen this up. Put our blocks in on each side. Tight. Just trying to make sure that it does not like dip down. So that would impact our squareness side to side. So it needs to be flush at the top and bottom. There we go. So our rails are now flush, or they should be set to the same distance here. I'm not sure if we can add the brackets up at the top or the bottom. I may wait and put the motors on and then figure out where I can add bracing here if need be. Okay, and yes, we got our big cup of coffee. Our plates here, this is our front. Actually, let me go through and see where we're at in our frame and see if there was anything else to add in the frame. Ah, yes, we need to take the front pieces off so that we can add in the screw pieces. So these pieces here, they have a spot for an M3 nut in the back, and then a spot for a 2x5 magnet in the front for the latch. I did print these with a little bit of brim on it because they, rather than sitting flat like this, they were sitting up on one end. Fine, I just put a little bit of a brim on it and they printed just fine. So we need to get a out the rest of our stuff like as if I was ready for the build process today. Standard parts, need these. Now we're going to need those. That one and that one. So, need M3 nuts and the magnet. Three nuts in here as well. Hey, Hybrid, how's it going, my friend? Welcome on in. As you can tell, I have not gone and parsed any of this stuff out, because I was planning on doing that tonight, and I figured this would be more fun than doing a screw sorting stream, right? There's some magnets there, so that's probably the magnets that we're going to need. Go through and just clean these edges up real fast. just scraping them off with a fingernail. Normally, once you get most of the brim off, you can scrape any little excess off with a fingernail or take the straight edge of a cutting blade and snap the rest of the little piece off. Be careful if you use your fingernail, because if you get a shard up underneath your finger, it will hurt. Okay, I need 2 at the top and 2 at the bottom. 2 at the top, 2 at the bottom. So we need 4 M3 nuts. These will press fit in the back. So Chris, are we going to get another stream before Midwest Rep Rap Fest, or are you pretty much done streaming for the foreseeable future? Okay, so those just press into the back like that. And then on the front side, we'll have magnets. Those are, switch to M5 magnets and M3 nuts, frame part of the magnetic door latches. 2 of the front lower and 2 in the upper extrusions part. Okay, and we've got 2x8 and 2x5 magnets. Nice. Kimmy's doing better on the leash. That's good to hear. These parts have been being printed on the X1 carbon behind me. So when I do these magnets, I'm going to take them and put them all in from the same direction. And hopefully they press fit in nicely. They're going to be a little bit tight, so we will grab our Nippics and use those to our advantage. Take that, get it right there on the top. Then we will line that up and push it down into the part slowly. Don't want to split the part. If you want to get these seated, it is a nice good fit, so we're not going to damage anything. Now I'm going to use that to make sure I get the orientation right for the next ones. I'm going to peel one off the top, make sure it stays in that same orientation. Get it on there for the next one and squeeze on the next one. That way they're all in the right orientation. At least all in the same orientation put in there. Oh yeah, that's definite. I've got a friend up the street. Well, I got a neighbor up the street, neighbor and friend. And they've got a dog they've been training for hunting, and his name's Gunner. And when he sees me walking up the street, just walking around or whatever, he will come barreling down the street after me, which is really cute. But yeah, I've got to make sure before I head up there, if I see that he's outside before he notices me, that nobody's coming down the street, because he will barrel right down the middle of the street after me and then almost knock me over. Got to be careful that he doesn't knock me over or knock my wife over in the process. He just gets so excited. So all of these parts here have been printed on the Bamboo Labs Carbon X1C. Same one that I'm using to print all the parts for your Rook 2020 kit. These are using normal Voron settings as far as number of walls, number of excuse me, number of walls and number of top and bottom layers. So I'm going to take a quick gander at and see if I can side is true and which side is that. Fastener. What I'm trying to do is figure out what's magnet and what is magnets on the right side. I guess I could probably look at the door latch part itself and figure up magnet. I'm just trying to figure out which way I need to put in when I take this top out. I'm going to take the top out and then take the bottom out, and then have to re-square this top frame. Right. You slide in. Have to take screws out to be able to get them all the way in. Screw out, drop the screw. And put the screw back in. And so the way this will work based on what I'm seeing is magnet on the left, screw hole that'll lock it into on the right. And we'll have to do that same thing on the other side. Directionality, so we lead with the screw or the M3 nut. Magnet stays on the outside. get this back into position. Washers right position between the head and extrusion itself. Now we'll be using our 1, 2, 3 blocks again. Keep things aligned. And don't worry, I will take this back downstairs and make sure that this is fully aligned and not twisted in any way, shape, or form later tonight. Because even if I flip this over, well, I might be able to get it nice and flush here again, doing it this way, I guess. Full angle driver. Once again, we're using the 1, 2, 3 block and one on each side to try and keep things parallel with the front and keep everything in a 90-degree angle. And I'm using the kind of the heel of my hand here to push down on the lower extrusion to make sure that it stays flat. And here we're going to undo the corner brace. Undo the end here. Should hopefully be able to lift this up enough. Now, we got to take the screws off the ends so that we can put our printed pieces in. We just won't make it in there any other way. Lead with the M3 screw first. In reality, I could just take one end off and push one all the way down, but my brain was not thinking of that, so I have to take each off. And we'll flip it back over and do the same thing as far as getting everything tightened and back in position. Yeah, I mean dogs are like that initially, especially when they're puppies, but you can get them trained out of that behavior pretty easily normally. go. That's in there. Flip it over. Get it flat. Bring things nice and tight. Pressure down to make sure that everything is flat on the workbench. Push together to make sure that we've got our everything parallel. Tighten the one side down. Move our blocks to the other side. Do the same thing over here. Push down. Make sure everything's squished together and perpendicular. Parallel on the front edges. Tighten that down. Get our other screws so that we can screw in our corner bracket. Right with it because it doesn't feel like it's twisting. You don't know what that was? What do you mean, tugboat? So I use 1, 2, 3 blocks when I do my frames. They're good reference surfaces, 90-degree angle reference surfaces for either keeping things parallel or making a 90-degree corner. So you put one in the corner and one along the outside edge. That'll help get this front or this rail parallel with the front. So pushing down is going to keep everything level at the bottom corner. One on the inside, one on the outside, squeeze together while pushing down, and then you tighten, and that gives you a nice, good, solid joint there. You accidentally copied the wrong thing. Well, that's bad. It's traumatic if you were like copying the wrong thing, I don't know, on a test. Hopefully you weren't doing that. Okay, so good there. Oh, that is the bottom. So we're good, and we're back to where we were, but with those pieces installed. So that's always good. Magnets back in there. We'll put with the M3 screws. Three screws. Toss them back in the M3 bags so we know where we're finding those. So we've got those put back into place. Now it does show adding the handles. We can add the handles now. We can hold off on the handles. I don't know. We can add some more corner brackets around the bottom corner and in the front now, so that we can once again make our frame as strong and rigid as possible. Matter of taking our corner brackets and that gives us 4 around the top. I can still do 4 around the bottom. We will be adding a bottom plate of aluminum as well. But I'm just kind of going with the however many screws that we can put into it, the better. Those we'll grab hammerheads here. A couple of more of our corner brackets. And I will go ahead and put some M5 washers underneath here. You're on mobile? Gotcha. Yeah, things are kind of more of a pain in the butt when you're on the mobile, huh? And just get these in place, line them up. Down. Watching to make sure that they do twist and you tighten them down, because if they don't twist, then not holding anything. Anybody got any plans for this weekend? Or Mother's Day weekend? I know I'm planning on moving into the doghouse because everybody wants me to come out on Saturday and join the gang at my brother's campground on Saturday, and I just kind of not looking forward to it. Not sure if we're even going to go. Oh, Zombie's birthday? I see. I keep forgetting he's got his birthday stream this weekend, doesn't he? Okay, so we did that. A couple of more brackets, and I think we've bracketed everything but the Y cross beams. And like I said, I just need to once we start putting the motors on, I'll figure out if I can put a cross or one of these on there or not. Um, for the most part, it is a pretty easy build. The issues that I've had are just simply some order of operations. Like I said, the manual isn't as clean as like a Voron manual, right? We've all been spoiled rotten by the Voron guys and their manuals. Um, but it's not too difficult if you build something before. Um, you do have to do a little bit of unbuilding with the Mellow kit because it does have the CNC gantry, and you'll have to take apart a little bit because they pre-build the gantry, but it's pre-built using PLA parts because that's the easiest thing to um, print in their factories. But beyond that, it's not too bad so far. And I would really want to do the gantry anyhow because none of the carriages were lubricated, so I needed to lubricate the carriages. Like I said, I think that's all of these that I can do for the time being until I start to put on the motors for the gantry, which hopefully we'll get to a little bit today. Don't believe there's any that go in the top front, um, like up here. I guess it shows them in the CAD. So that, yeah, nothing's going to come up here. So I can put some up here in the top as well. I was just holding off to, I'll hold off and do those when I figure out if I can do any on the Y rail. So we have all three corners, all three corners, all three corners in the back. Two corners here, we need to add one here, and then whatever we can do on the Y rails once we get those squared away. That in there for now. This is the printed jig that we were at. The next thing, like I said, I'm going to hold off on putting the handles on there just for a little bit. We'll probably put them on right before the end of the stream. The next section goes into the bed assembly. I'm going to scroll through it here because we have the CNC kit. I'm just going to kind of get through adding the bed section there and the gantry as well. We'll follow the CNC and aluminum guide for both of those. Jump over to this one. So this is kind of where we stopped off yesterday. We got things kind of loosely put in place and they were just sitting there held in place because I needed to print this jig. Got this jig printed, and what I did was I sat it right on top of these corner brackets, pulled it in tight, and then slid this over to where it's matching this curve, and then that's where I locked these both down. I did this on both sides using the same jig so that both of these are going to be the same distance from the front rail. Okay. Um, yeah, so we did this on both sides. I did not put any Loctite on any of these. They're just going down into the T-nuts. Normally I don't Loctite those screws. What I will do is I'll run it this way, and if we have any issues, then I will come back and, you know, Loctite them if they start loosening up with vibrations. So budget I get, confidence, like I said, the Voron documentation is really, really good. So don't be, I'll say, too worried about your skill. The documentation is very good. Shouldn't have any problems being able to put together a Voron, whether it's a Trident or a 2.4. So we set the distance. We lock these down to include our upper bearings. I just moved the lower bearings just to visual alignment. I know it's not perfect at this point. Mount the lower lead screw bracket using two M10 or 2 by 10 millimeter M4 screws loosely to the frame, approximately in the correct position relative to the top bracket. Mount the lead screw bracket, the top bracket, which we did. Insert the pulley with the closed belt and insert the lead screw, then tighten the grub screws on the pulley. So that's the next step that we're going to do. And what we're going to do is clean up a couple of things here. I need to get out my lead screws. I'm going to put my paper towel down here. Slowly out of the way there. I'm going to put my paper towel down here because I need to put Loctite on the set screws on here before we go to use these. So I just need to make sure and have something there that, one, I can find tiny little black set screws because I have a black table here. And also something that if I drop the screw, it shouldn't go bouncing all over the place. Probably the tiny 1.5 ones. Oh, the 2.0s. Grab our Loctite. Once again, after seeing the sticks used by Steve Builds, I really like the sticks. They can dry out some, so you do have to be careful of that. But, and I just dropped that and did the thing I said not to. Me and this set screw are going to have issues. There we go. It can dry out some at the top, so if it does, just, you know, go ahead and wipe some of the top off, or just use something to scrape a little bit of the top off. You'll get down to some moister portions of it, more paste portions of it, that'll work well. I try and keep the lid on it as much as possible, but it does dry out some even with the lid on there. If you're using the standard liquid Loctite, that's perfectly fine. Just get like a little plastic dish, or what I use is like little condiment lids, because you can squeeze a little bit out onto that and then just dip your screws in it. Oh, heck yeah. That's why if you're going to build and you have animals, I would highly suggest having some type of build mat, whether it's like a silicone mat like this, because things don't tend to bounce and then bounce very far. They'll hit, and normally the silicone mat or the like the one I had on here before from Fader, or what, the neoprene mats, things don't bounce off of them as easily. So we've got our set screws ready, and looking at this, it looks like these go upside down. So the set screws are towards the bottom. Okay. And we're going to need the belt and our lead screws. So let me grab my lead screw now. And where was my belt? Don't think it was in this box, so it might be. Yep, no belt there. Where is it in the accessory box? Well, there's some belts. This is a looks like the closed loop belts. Say which. No, it does not. So yep, this zip tie. Okay, this is the closed loop belt. So this will most likely be it. It's going to go around both pulleys and then the motor in the back. So it will get stretched between all of them. This looks like a 860 millimeter closed loop belt. Hey Bexy Beans, welcome on in. How are you doing this evening? Hopefully you're doing well. So we're going to take this belt and loop it around our pulley, and then we're going to slide our pulley between our two bearing pieces, kind of line it up, and put our lead screw right down the middle. Okay. Then we're going to do the same thing over on the other side, making sure that our pulley is down, looping around that pulley, sticking it in the gap, and then putting our lead screw down the center. Okay. Now what we'll need to do is tighten up our set screws So the metal parts right now, everything is sitting flush on my workbench, and that's perfect. We want the lead screw to be going all the way through the second bearing that's down at the bottom, because that's what's going to hold this in the correct position. So now we need to go in and tighten our set screws up on the motor, or on the lead screw. So we get both of them. Okay, and once again, the top is tightened, and we're tightening the pulley onto the set screw, but the bottom bearing is still not tightened down. So that's where we'll be measuring here in a minute to make sure that we've got equidistance between each of the rod and the lead screw, because that will tell us if our lead screw is perfectly vertical or not. And if it's not, we should be able to nudge the lower bearing one way or the other and bring this distance in so that it's equidistant on both sides. Once again, we've got several pieces there that I'm probably going to have to move out of the way because they'll be in my way. Hey, Nick, how's it going? Oh God, yes they do. But once kids get going, it's hard to get them to stop too. Okay, sore from the gym though. Be in and out as watching TV too. Okay, good. Hope you're having a good day. I am. I'm having a good day. It rained a little bit earlier, and because of that, I can't do the yard work. So I get to do a little bit more streaming because I kind of got a hall pass because it's too wet for me to take I've got a 0-turn mower. So it'd be too wet to really get that out there because it will just bog down in, and I'll put ruts all through my yard. Sorry there. Okay, so lastly, while making sure the lead screw is perfectly straight, tighten up the screws on the upper and lower lead screw bracket. This can be checked by measuring the distance on both sides between the lead screw top position and the 10mm rods. There's a couple of ways that you can do that. You can use your Mark 1 eyeballs and a straight edge, which is what I am going to use because, well, my things are dying a good death. So once again, I'm just going to stop moving this. And measure this. Mark 1 eyeballs. We're going to have to try and use the calipers. I'm going to go as high up as possible. way off. So. I think I'm going to have to lock these in and then make the adjustments. There's a little bit of play. To bring the bottom toward. Once again, minor changes at the bottom are going to have larger effects at the top, so just be aware of that. Pretty close. Good there. Bottom's going to need to come towards me just a hair. Too much of a correction. issue. Tighten down the one side, it kind of rotates in. This is where you just have to take your time. Take your time, and you really want this to be as accurate as possible, because it will reduce any chances of binding in your bed mechanism down the road. Overcompensated. Remember, a minor change at one end can lead to a large change at the other end. I think we're pretty close right there. And we'll adjust once we get the bed itself in. I remember right from reading ahead. Hey, Steve, how's it going? Welcome on in. Benchy, Pete. I know we're kind of doing an impromptu stream right now. We're going to continue working on the VzBot a little bit. I did put this downstairs and square up the frame last night. We did get the printed parts in here, so we set the gap for these rails. We've added some additional corner brackets that I ordered and got in overnight. We set the distance for the rails based on our jig. So, and now we've just added our 2 pulleys down at the bottom and then secured our bottom plates, making sure that we've got equidistance between our rails and the lead screw at the top. That way our leads or our bed should be able to travel straight up and down with no issue. Trying to make sure that I did tighten this up. Cannot seem to find the screw head. Did. So this is a closed loop belt. So both lead screws are driven by a single motor that will be mounted in the back here. I think that's one of the things that we'll be doing. So now we're going to assemble the bed frame, and we'll add that to the printer. What I'm going to do, stopper to the back and see if I can move this further down out of the way. Hopefully it's not going to be in the way of putting the bed on later. We'll have to remove the stoppers altogether, but I might put something, I might have to put a motor mount back here just to keep these from rolling off. Yeah, place the bed assembly the rods on the lead screw. Here we go. Let's grab what we're going to need. I'm going to take this and set it off the table for a moment. And try and straighten some things up a little bit. These printed parts are going to get pushed just to the side. So I have a place to work here. Okay, so we needed the bed frame. Which, once again, folks, this is bloody work of art. This is got that. We're going to need our 4 bearings. These are our LMK10 LU. We're going to need 4x8 screws. By 8 by 8. There's 4x8s, 3x8s, and 3x50s. Those are going to be some fun ones. Hey, Abaddis, how you doing? Oh yes, this aluminum stuff is very nice. In fact, I was looking at some of the other aluminum pieces that they have. Sorry, folks. Let's see, M3x8. These are button heads. 3x50. Or something bed M3x50. 35s. 40s. Countersunk 40s. 25s. Those are the only countersunk ones that I see are 40s and 50s. So we'll have to check that out. We'll also look at the other, that nondescript packet, and see if it was in there. See if they may be in there. Does not appear to be. So we'll have the 40s. We'll keep an eye on that. There are 4 of those, so I'm assuming that those will be correct. We'll need some M3 nuts. Grab those out. Oldham couplers, optional but highly advised. Yeah. Put them in there, so might as well use them. Oldham couplers. And lead screw nuts, which are part of the Oldham. Bed level adjustment knobs. We've got 4 of those here. And we're going to mount the 4 LMK10 LUU, and we're looking for where the VEZ is at. I'm going to match it to that diagram. So I'm going to have it bottom right hand corner, which is where the VzBot logo's at. Open these up. And we're going to piece of our paper towel because they're a little. Now the question is whether there's actually grease packed in here or if they're just sitting in some lubricating oil. And of course, I do not have an LM10 adapter for my grease fitting. Because normally what I do is I'll take a bit of super lube and we'll lubricate the LM8, normally the LM8 UU bearing, but similar to like what we do before, we have a cap on here, and the cap has 4 little cutouts on it. So you would take that, line it up with your bearing, put the cap in, and then squeeze. The problem is that that's for an LM8. These are LM10s. So we may have to try and print a new adapter if I can find one. Because the other option is to just use one of the rods, which kind of sucks since the rod's already mounted. But basically you do like we've been doing our needle bearings. You take take and squeeze a bunch of your lubricant in there and tap the other side and then just slide it right down on your rod and it will force it into the bearings because it has no other way to go. Hey, Evil Diesel, we're doing good. We are opening up the LM10 KUU, LMK10 LUU bearings. Wow. So the LMK are basically these bearing blocks, and then there's 2 bearings in there. And as I was saying, I don't have a 10 millimeter bearing fitting on my tube of super lube. So I'm just going to squirt some in there, and then I'll run it up and down the rod, one of the rods, to actually peak it or pack it in. Similar like what we do on the extruder needle bearings, where you see me squirt some EP2 in, and while holding my thumb on the back side of it, we'll stick the 3 millimeter rod in, and that ensures that the grease gets packed into the bearings. So we're going to have to kind of do that. But these are packed in a light oil. So that's what you see me doing, is just wiping the light oil off chassis casing. I'm not too worried about mixing grease and oil in the bearings because, like I said, it's just like a light oil packed on them to keep them from rusting. But that means I need to put the printer back up here. We scoot this to the side. We'll put the printer back up here so I can work on trying to pack the bearings a little bit. grab another glove here because folks, making greasy. How's it going tonight, Evil Diesel? I would ask if you've broken anything again, but I'm pretty sure I know the answer to that. I'm just going to stick this in there and I'm going to roll forward and squeeze some of that grease into the casing. And then we're going to slide this down on there. Once again, putting my thumb at the opposite end. And the rod is going to provide pressure and squeeze stuff into the bearing. And then me putting my thumb here is going to keep it from squirting out as much. And this will ensure that we get grease down into the bearings with a little bit of squirt out. So grab our other paper towels that we had down here. Now, what I'm going to do to make sure that I get it all the way down through the bearings is now I'm going to reverse it. Get it on there, cover up the other side, and slide it on there again. Just to make sure that we're fully covered from both sides. That one done. There for now. Next one ready. Pour a whole bunch in there. Wipe it off as we take the lid out. Line it up on the rod. Thumb over it to create the pressure. Over and put it back the other way. Again, we're just making sure that we get it pushed in from both sides. We may do this once or twice just to make sure that we get them well packed. Last thing you want is your bearings not being well packed and having to take this back off and redo this. Got a couple of printers going at this time. Well, that's good. Eventually we'll get you going with like 3 or 4. That was good. That one was good. That off and stuff it in. Always a good day when you got to fish it out of the screw holes. Last one. And like I said, if this was a 10 size or these were 8 size bearings, it would very nicely pack those, pack that grease directly into the bearing channels with no issues. We can work with what we got. I'm just going to grab this and wipe this excess grease off the rod. And of course, off of my cap. Throw that away. Super lube covered back up. And take that glove off. So we've got our bearing blocks lubricated. Easiest time to do it was right there. We're going to set our plate back down. And these come in from the top of the plate. So basically we're going to stick them like this. And our screws are going to go down through the top here and screw directly into the aluminum plate. So these were with the M4 hardware, so that would be the M4x8s. Need like 16 of those. Because this is the bed frame and we're screwing down through here into the directly into the frame, I am going to go ahead and use Loctite here. And I am going to verify just real fast that my M4x8s are the button heads and not the like socket heads. Yeah, because the socket heads, there's only 2, so that ain't going to be enough. So boom, problem solved. It's the button heads. A bit of Loctite on the threads. Up, get our screw going. Not going to screw it all the way in. What I really need is Polymaker boxes are used for everything. Hey Glendon, how's it going? Yeah, this is a pretty beefy plate. You're going to have to become a Twitch streamer so I can afford another couple of printers. I got news for you. This Twitch streamer ain't making much. Definitely not enough to afford a couple of printers, but Then again, I may have a printer or two that you may see up for sale, like a, I don't know, a Prusa Mini with the Bondtech integrated filament sensor and a Revo micro hot end. Really just because I'm running out of space to build printers. I'm going to keep these just loose enough that you can move things around to get your screws all aligned and going in. That actually just, like the screw head is not getting down in there. I think the might be a machining on the hole issue. This. I have to hold off on that particular one. See me get these started in a crossing pattern, and that's just to make sure that we can get all 4 screws in. Everything stays loose until I can get all 4 screws in, and then I'll tighten things down. Tunnel to the bank. Yeah, might work. Not going to advocate it, but be a drug mule. Seriously? Plenty of time to sleep on the plane? Oh, you're assuming you get to go on a plane. That one was just awful tight to get into the like it. I think it's catching in the hole itself. Well, I was kind of surprised to see them using button heads because normally I would have assumed they use socket heads here. And if I had socket heads in an M4, I would have used socket heads here regardless. The socket heads, the the head of the bolt itself isn't as big, so it sorry, it gives you some more wiggle room basically. Because here it feels like what I'm doing is catching on the head of the bolt in the counterboard hole area. Get this with the M4 hardware. Never said anything about how you got to come back. That's true. That's true. 40. You might want to take first class on the way there because probably coming back a more painful route. No. Yeah, that's actually the head of the bolt fouling in the drill counterbore. I don't know if the counterbores are crap or if there's a tolerance issue with the head of the bolt. Don't know. All right, shenanigans. Be safe at work, my friend. Stay safe on the road. And it hasn't really said, it says mount using the hardware or mount using the M4 hardware to the bed frame, then mount the Oldham couplers to the lead screw with the M3 hardware. Mount that assembly to the bed frame using M3 hardware. Doesn't say whether to keep it loose or not. I tend to keep it loose just to help with alignment and getting it on those rods. Because the last thing we want to do is have things so tight and then we put them down on those rods and we kind of bend the rods in the process of getting the bed onto them. So I prefer to get it onto the rods and the lead screws and then tighten things up. Because like I said, there's a little bit of shift and wiggle here, not a lot, but there is a tiny bit. Get these a little close so that they're easier to final tighten down once we get it on the printer. No, actually, I think I am going to go ahead and tighten them down. Leave the Oldham couplers loose. Feel like they're lining up well with the edges. So. Go ahead and do an ug-a-dug on them. May bite me, but we'll adjust fire if we need to. Counterboard. Really weird because that brand of bearing I thought was a good brand. Heating on these counterboards is Garbo. I wouldn't expect the tolerance on the screws themselves to be. what I'm doing is just kind of looking at the screws themselves to see where a screw may not be as far down as the rest of them. That may be a target of where I was hitting a counterbores here. Again, this is not an issue with the threading of the CNC plate. This is an issue of like the screw head tolerance in the counterboard dragging on a side. And I feel it kind of break loose and get around there. So it's like the counterbore is off center. I don't know. It's weird. It is just weird. Okay. And tight. Oldham couplers. It was talking about joining the Oldham couplers and then mounting the Oldham or the blah, 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 blah. So our Oldham couplers are made so that they can slide around and 3 different axes. Never going to slide that much. Made to be able to slide around. So it says mount the Oldham couplers with the lead screw nuts together with M3 hardware. Mount that assembly to the bed frame. That I'm kind of confused about. I think it's kind of saying that you would have an Oldham coupler and that you would mount the lead screw nut to the Oldham coupler. But with the way these are designed, you can't do that. Not another lead screw nut. The lead screw nut is cut and designed into the Oldham coupler. So all your Oldham coupler is a couple of chamfered dovetail joints so that one piece can only slide in one direction, the other piece can slide in the other direction. That's what allows the degree of movement as you go through your lead screw. So I think what we have to do is just mount the underside here using our longer lead screws based on the way I'm seeing head mounted here. Go to the pad and see if I can. No screws in that. So let me go full display here. So once again, this is the Oldham coupler. 1, 2, there's the third piece, and then it shows the brass nut, which is weird because this shows basically a separate Oldham coupler and then a brass nut. This is an all-in-one Oldham coupler solution. So we're going to we need to screw the Oldham coupler to our plate, going through the Oldham coupler into our plate, because the threads are in the plate, not the Oldham coupler. And then the other side of the Oldham coupler is going to be just loose, because that's the slide that's going to fit onto our lead screw. That'll be fun not to throw it everywhere as we actually put them on the darn. This we had M3x8s, because it's not showing any bolts at the bottom side of it, and I'm pretty sure if I look at the top side, it'll have a bolt going into the frame. Again, I want this to be secured, so I will use a little bit of Loctite as I screw the first section of the Oldham coupler to the frame. Hey, Rodney Mac, how's it going? So, a little bit of our Loctite. Down through our Oldham coupler into the frame. Close, get the other screw done so I go on nice and straight and parallel. Screws tonight. Once again, we're doing button heads on this, but with the way these are cut, you know, button heads or socket heads would work. And then once again, the rest of the Oldham coupler will just slide on there like that. And you will not have any screws here, because these are not threaded holes. These are through holes at that Oldham coupler, and there's nothing for it to screw into. So this is going to be completely free floating on the lead screw. That'll be what sets us up for keeping, well, it allows for a little bit of play in the lead screw. Other than blood pressure, not too bad. Uh-oh. That's not good. Really? Yeah, this is a nice thick aluminum bed. And then we'll have a nice plate that gets mounted to it as well. Getting a little bit of Loctite on our threads. those are screwed down. Line up our Oldham coupler on this side and slide it back on. That. Okay, so our Oldham couplers are in there. Now we're going to place the assembly in the rods and lead screws. Now we're going to add it to the printer. And once we get it on the printer, we'll mount the bed to the bed frame using the 50 centimeter countersunk M3 screws. Using a cast aluminum bed, make sure it is well prepped for mounting. It is recommended to always be safe and inform yourself properly on how to apply an AC silicone heated pad. So I got news for you. We're not installing the build plate just yet. That's kind of our thing. We always wait to install the build plate just because, well, it's heavy and it sucks. So it adds weight unnecessarily when you're trying to move the printer around. That's normally one of the last things I do is install the build plate. So we'll hold off on that for now. Unless I see something else in the instructions later on that kind of says, hey, you want this there now before going any further. Out of the way. There. This over here. We need to put our printer back up here. And our carriages are going to be in the way. So we're going to have to be very, very careful that we don't knock these off the edge. Take the rubber stoppers out. Slide them back. Need to be careful that we don't knock them off the edge. Our plate is going to flip over. Oldham couplers are going to make it all kinds of fun. Try and get our bearings lined up on one side. Other. There they go. Lead screws need to align. Kind of the fiddly part of things. Lead screws, we're going to start turning to engage the threads. Engaging on one side, not on the So we've got all of our 4 rods on, and we've got our lead screws just kind of right to the top of the build plate. I'm going to wipe off some of this excess grease that popped through the top. And where we're at right now, what's it say? So mount the bed plate to the bed frame using the 50mm countersunk screws. We're not going to mount that plate to the thing just yet because it adds unnecessary weight. We have our top rod mounts. We'll need 4 of those. And let me grab those. Once again, these are some CNC'd aluminum pieces. And once again, very nice CNC'd aluminum brackets. There is one that will have an extra hole in it that goes in a specific place. Or actually, they all have that hole, so that's nice. I don't have to worry about which one I put it in. I just have to worry about which one actually put the whatchamacallit, the thing on, the end stop on. I'm going to put these stoppers back in there so I can move these around and keep them on there. Very bad to drop them off at this point. We need some M4x10s and M4x20s and some M4 T-nuts. M4x20, 4x10, and it really doesn't tell us whether or not we're using button heads or socket heads. I really wish it did, since they're providing both in the kit. I really wish they said which ones they're using. Looks like we're going to be using the M4x10s. Going through the bracket and through a T-nut. And then we're going to be using the M4x20s as the clamp. Four of those. Four of these. Exactly what they are. So we'll get these started, and I will probably put a little bit of Loctite on those. That's going to go pretty much the entire way through there. Not sure why you would need that on a clamp, why you would need to go completely through the aluminum piece, but so be it. Get a few threads going and get these started. Just getting these started and bottomed out, and then I'll come back in and yeah, like I said, I feel like these do not need to go all the way through to clamp these rods down. I have a feeling like we could have done with some M4x12s like we did below. I don't know why the loads would be different on the top versus the bottom. Right now, I'm just getting these aligned and set up. Quite honestly, I am, but I'm not going to follow the directions a little bit here because I'm going to set it up like this, and then I'm going to clamp the arm on. Lightly, not like complete ugga-dugga. I just don't want it to be able to slide. Because what my plan is I'm going to flip this over to do my M4 nuts. And I'm going to use the bracket as my guide for where I need to put my M4 nut. As well as to hold the build plate from falling back off when I flip this thing over. Close. Because it tells me to use a type of T-nut that the only way I could get that in there is if I took this back out, which I'm not going to use. I will use pins. That looks like a standard slide-in T. Mount the 10 millimeter M4 screws and T-nuts to the top of all mounts and loosely turn in the 20 millimeter M4 screws and the clamping mechanism. Mount all the top rod mounts to the rod first. Make sure the rod mount and the extra hole for the Z-limit switch is in the back right of the printer, like shown below. This is the front. This would be the back right. There's a Z-limit switch right there. Goes more like it would be the Z-limit switch back here. It's there. The Z-limit switch is there. Like I said, what I want to do, I'm going to stop the bed from popping back off. Flip this over. After installing, check the movement of the bed, but we'll tighten the rod holders to the frame with the pre-inserted info hardware shown below. Going to pray that nothing shifts. One of those clamps. So apparently I didn't have that one tightened enough. On, turn around. But what this will let me do is I can drop in my M4 nut, slide it under, get it lined up, put my M4 in, tighten it down. And right before I tighten it down, I'll let this go, but I want it somewhat tight before I start to do that so that the bed itself doesn't drop. Hey, Chaos Drucker, how's it going? Welcome on in. Rate of 98 people. Holy cow, or 96 people. Holy cow. Hey, Bionic. Whoops. Me switch cameras real fast. Welcome on in, everybody. My name is Digital Dragon. Welcome on into the Dragon's Den. We are working on building a VzBot 235 kit this evening. Thanks for popping on in. Chaos Drucker, Zenberg, hello, hello, hello. Jumping from the pool edge, there you go. Captain Chaos, welcome in. Welcome in. Wild Sheep 007, good to see you again. Hey, Zombie Hedgehog, how's it going? So yeah, we're working on a VzBot 235 kit and trying to decipher a little bit here and there on the instructions as we go. Sometimes you got to do that. This is a CNC'd aluminum kit from Mellow. So some of our parts are CNC'd versus printed, and others are going to be printed. So that's where it's kind of a little bit more of a pain, is to try and figure out, do I need this part or that part? Or is this a CNC'd aluminum part versus a printed part? And yeah, so we're making things happen. So welcome on in. How was your stream tonight, Chaos Trucker? Or anybody that's popping in with them? Hopefully you guys had a good stream today. This is not a regular stream day for me. I will say I got a little bit of a hall pass because it rained. So I didn't have to go and do yard work this evening, which was nice. Am planning on trying to put a little bit of Loctite on these particular screws. And use my 1, 2, 3 block as well to make sure that this bracket is fully parallel to the side and doesn't twist around as I tighten this up. Welcome on in, Raiders. Appreciate you guys popping in. Oh, I'm sorry, I didn't change the screen back. So change the screen back to the one that actually has my instructions on it as well. And this is what we're working on, is installing the CNC bed mount system for our VzBot. These are very, very nice CNC'd parts. I'm just trying to make sure that these stay flush with the edge so that they don't run afoul of our whatchamacallit, our panels later on. So far, I mean, I've got a lot of Vorons. I did Annex Engineering K3 not too long ago. I really like that. So far, there's a little bit of a, the instructions aren't 100%, I'll say. But we are able to get it done. And some of that is because we're having to jump between manuals. So like there's a manual if you're doing all printed parts, and there's a manual if you're doing the CNC aluminum part, right? So that's where a little bit of this comes into, where we have to kind of finesse things a tad bit. So that part is a bit annoying, but I guess it's also the same if you're doing like an LDO motors boron kit, because you have to keep jumping around to the LDO, between the LDO manual and the standard boron manual. Yeah, so far the build's going pretty good. The other part that was, I'll say, kind of a bear is trying to figure out what parts you need printed between, because you look at it and normally you say, okay, I need to print all the parts in this GitHub, right, for a Voron. Print all the parts, right? Well, here, you've got some parts that are only going to be used if you do um, the fully printed kit versus the CNC kit, and then you also have well, like, you can do this option or that option. You can do this or you can do that. So you kind of have to make decisions while you're trying to decide what parts to print out for your build. And it's a little more cumbersome because of that. Not gonna lie, but overall, not too bad. So all four of these clips are drilled exactly the same, which means two of them you're screwing from an outside, so you can get a really good angle on them when you're clamping them. And the other two you're getting at from the inside, which is kind of a pain in the butt. And I can't use the same, my good neural driver to really tighten down on it because of the alignment of everything. Everything good. Slight tweak there. Looks like there's some play in this one still, like front to back, side to side. So this one's really loose. This one has some tightness to it, to its movement. That's kind of interesting. But I think that's the purpose of Oldham couplers anyhow, is to try and take any variation out. We just had a get together and had a few VzBots at the event. In addition to the instruction, there was also some criticism that a lot of the different screw sizes are used compared. Exactly, there's a lot of different screw sizes. And once again, the instructions are saying, M4 by 10. Well, I have M4 by 10 button heads and I have M4 by 10 socket heads. And looking at it, I just put button heads right there, but looking at this right here, that looks like an M4 by 10 socket head versus a button head. So I may have to go take these mounting screws out and put button heads in, or I'm sorry, socket heads instead of button heads. Four by 10. Yeah, because I do have M4 by 10 socket heads versus the button heads. So now I need to go and swap that out, because once again, like in the in the Voron documentation, one, they try and use all button heads, period, end of story. And if it's not a button head, then it's a flat head. Here it's, yeah, it just, and honestly, I was going to spend tonight sorting these screws, and I'm streaming instead. So, I mean, I could do a screw sorting stream if you guys want, but for now, I will take these out one by one and swap them out for socket heads. The other thing that I will say as well, and this was rather annoying in its own right, is I do my normal thing. I go to GitHub and I download the entire GitHub repo, right? It downloads, it says you have to use 7-zip to unzip things, but I unzip the repo because it downloads as a zip. And then it's got files that say they're STLs. And every single STL file was like 131, 132 KB. None of them will open up because they're not STLs. I don't know if each individual one is zipped, but I downloaded it on a Mac and a Windows, and I basically wound up walking the entire tree and downloading every single STL in case I needed it. That was a tad bit annoying. Oh yeah, the CNC parts are gorgeous. Cannot complain about the CNC parts. I was looking at the CNC'd X-rail because the X-Gantry that comes with this kit is carbon fiber tube. And I was looking because I know that I had watched Vez do a comparison of the aluminum and the carbon fiber. And all in all, I think he came out with the carbon fiber. And believe it or not, the aluminum tube is actually lighter weight than the carbon fiber one. But it did seem to flex a little bit more under just a plain static load. And then with after he baked them at 175 degrees Fahrenheit for, I can't remember how long, basically simulating a heated chamber, it still flexed, sorry, a little bit more than the carbon fiber did. So I'm kind of, I've got a carbon fiber one. I'm planning on using the carbon fiber one, but I did check to see, like, would it be cool to do the aluminum one? Yeah, it would be, but it sounds like the carbon fiber works just as well. I mean, they're really comparable. There's not much difference between the two performance-wise. It's just whether you're good with the carbon fiber look with everything else CNC, right? Now the front cross brace and the handle do not come in the kit, CNC milled. So you still have to print those. You can buy those separately, and that package is like $100 basically from Ollie. So you will have to pay another $100 to get those, but they work for either the 235 or the 300 or 330 build. So that's good. The LDO rails. So the gantry comes pre-built, but it's pre-built with all PLA parts. So you're taking the gantry apart anyhow, and you can't hang the gantry in here pre-built, or at least not very easily because it uses blind joint, right? So you would have to do I had to disassemble the gantry, and then once again, all the rails are mounted, and they're mounted well. but none of them were lubricated. So you have to go and lubricate your carriages. And for whatever reason, these are all LVO rails, all LVO carriages. Whoops. Let me hold that thought because we are in an ad break. Let me hold that thought because we're in an ad break. Okay, so we swapped the 4 mounting M4x10s over to socket heads from button head. So we've corrected that mistake of not reading or looking at the instructions well enough. Really, really wish they would call out the type of fastener size. All right, ads done. Community should be back now. So yeah, you can spend some bucks on the build. Well, like I said, the VzBot, or sorry, VzBot, the Annex Engineering K3 isn't a cheap printer by any means either, right? Oh, that would be, this lead screw is down just, might be what. Let me see about fixing that. The other thing that I was noticing was sorry, I just noticed that one of my lead screws was a little bit further down than the other, which may have been causing this one's. So words on stream up is something. Yeah, I mean the Annex Engineering K3, you can spend a good deal of money on those as well, right? Hey, Creatix Brit, how's it going? Welcome, 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 friendo. The I kind of like this double lead screw single motor setup. I did that on my Bugaboo, but that's a triple lead screw, but same kind of difference, and I really like that setup. Really like that setup. Okay, a couple of the other things like the instructions, it calls for this slide-in T-nut. Well, they didn't tell you to preload them, and it goes on the underside of this piece. So if you did it with blind joints, the way that the frame is, you're now taking off the top, you're taking this out, you're putting in some slide-in T-nuts. Like show roll-in T-nuts if that's what you're going to provide in the kit. Even though they did provide some of the slide-ins, they're not telling you to preload them. So on the M4s, we've got the M20s secured. Here the rod mount and the extra hole for the Z-limit switch is in the back right of the printer. So I assume so. After installing, check the movement of the bed assembly by turning the lead screws. This should operate smoothly. Okay, so what you mean by operate smoothly? We'll put a belt in there. You guys think that this is operating smoothly? I think it's operating pretty good. Doing good, Britt. Doing good. How are you doing? Yeah, send it. This bed assembly in the topmost position, untighten the top rod holders and retighten to rods. Single motor bracket. We're going to start working on our motor. So we're going to need some M3 by 10, M4 by 10, M4 T-nuts, and everything. Okay. Sorry, folks. Everything looks like it's a button head. And that looks like it's calling for the M4 hammerhead nuts, which, as we have discussed, I hate with a bloody passion. And I don't think they actually provided any. I think they only provided the roll-in T-nuts. I'm going to grab a couple of those. Need a couple of those. Going good, Britt. How are things going with you? Long time no see. I keep looking for your stream, but you've been actually streaming on a lot of other people's streams lately, haven't you? Need 4 of the M4 by 10. So there's 4 of those. Need 4 M3 by 10. I think I've seen you on some other people's streams. Oh no, your PC's down? That's not good. There's 4 of those. Need a .22 GT2 pulley and a motor. So motors. Where'd the motors go? This is big motor. This is a Tuner motor is going to be a pancake. 4 for the gantry are already there. That is a beefy boy. 1.8 to 17 max power. .22 STH60 2004 AC. That is massive. I've never seen one this size used even on a double lead screw like this. fairly nice pre-made cable in it as well. But that would be the only other motor because the other 4 are attached to the gantry already. So here we go. Motor box out of the way. And we're going to the back side over here. Actually, let me get the, where were the pulleys? Hey, there's a pulley. That screws in here, so we'll go ahead and get our set screws popped out and get some Loctite on them. So Britt, I gotta ask, because I know I was working on Dio and then I kind of stalled out. I got the new servos for the head because the original ones I put on were just way too light and the head was flopping around. But have you made any progress on your cheap? Because other than having my chopper printed, I still need to, I don't know, sand it, paint it, start assembling the parts for it. Maybe actually order parts for it too. I might want to do that soon since we're supposed to have these at 3D Printopia. Okay, so this gets mounted with the flange towards the lower side. We don't have a printed tool to tell us where to mount it. We will have to figure that out and line it up with the other 2 pulleys when we get this mounted. So for now, we're just going to loosely cinch up the set screws while we get everything put into built. We're going to need a couple mounting brackets. Those are here and here. This around so that we can start working back here at the back side. Piece of tape is our front side. This is a symmetrical machined part, so it doesn't matter which side we put where. And this gets put on with 2 of our M4x10 and T-nuts. But yeah, these are definitely, I'll say, a little bit more of a labor of love. Like, you can tweak the heck out of them, but they're a little bit more, even on the quote-unquote standard kit from Mellow. I remember watching ModBot and Steve Builds do theirs, and it was kind of a little bit of figure it out as you go. I shouldn't need to put Loctite on these. I'm going to get these set in there somewhat loosely so that we can figure out the location. It doesn't actually tell me, like, do you center it? Do you offset it? Oh, it does say, make sure it is nicely centered in the middle of the frame. But it doesn't actually give you any measurement. Well, We'll have to try and figure that out. Those of you wondering, it's going to be approximately 174 millimeters from and 76. About 175. Center it nicely. Just going to push that bracket forward so it's flush along the back here. Give it a good crank. The last talk, you found some more inspiration photos for the design. Okay. Sounds good. So we got this center, we got it mounted. We're going to mount the stepper motor to the top bracket using M10 by 3 screws. Attach the motor pulley as shown. So we got the motor pulley as shown. We're going to take our motor plate, put it on there. Mindful that the your connector is facing the back sliding portion. So facing towards the back of the printer. We're going to be using our M4 by 3 screws. Excuse me, our M3 by 10. M4 or M3 by 10 screws. Once again, you can use Loctite on this if you want. You're going through all metal parts into a metal motor mount or into a metal motor. So I guess technically there's nothing that says that you can't use it. Go ahead. I mean, we've got this nice CNC kit. It's going to have the potential for moving fast. We can also work on making it hot if we really needed it to. And I know that there are mounts and stuff out there for the Goliath. This comes with a Goliath. I do have a tube that I got at Rocky Mountain Rep Rap Fest, and I've also got a Takado hot end. Trying to figure out where I'm going to use those at. One of them may go out to the Trident 350. Just haven't decided yet where I want to put it. I've got a Trident 350. I also have a Ender 5 Plus that's been converted into a 0G Mercury 1 that I do all my helmet prints on. And that might be a candidate for one of those higher end hot ends, just to be able to. I mean, I've got a Takado, which is a super volcano size. So I've got two 100 watt super volcano heaters for it, and PT1000 thermistor, of course, and a 1 millimeter hardened super volcano nozzle. So basically, I should be able to push a lot of filament through. Mount the previously mount the previous assembly to the bracket using 10 millimeter M4 screws. Motor in the furthest position. Loop the belt around the motor pulley. Tighten the belt. Be sure to check the belt is horizontally parallel to the frame for smoothest operation. So this motor is going to sit like this using 10 millimeter M4 screws. And we are going to put some Loctite on these bad boys. We are threading directly into the aluminum mounting plate down here, so we will get this lined up. And Britt, are you going to be coming to Midwest, or are you just going to 3D Printopia? Okay, so that's there. Now we want to work on getting our belt on our each pulley, and we want to keep our bed level in this process, getting the belt down, back, up. That's pretty tight. Go ahead and lock these M4 screws in. Unlurk. Hey, hybrid, how's it going? So this is now pretty taut. We're going to say bed is moving. Now the question is whether the bed is fully aligned or not. Like this side is a little low. I'll loosen the tension on my belt. Wanting to do is get them both at the same height, getting them grounded against their pieces. They're fully grounded at the top. They grounded, meaning they're fully touching at the top. Just let this one slip that back. Tighten this back up. I'm going to flip this over and take a look at it and just check my belt out and see how straight we are, and that, make sure we're not changing heights and drive our belts. Might want to raise the pulley up slightly. There. Belt centered on your pulleys so that they're not riding up on an edge, because that will start chewing into your belts over time. I think we're good there. There we go. So we've got it parallel to the frame for smoothest operation. Need to add the D switch and the bed chain, both of which are going to be on the back side of the printer. So I'm going to flip it around so that the back side is facing me. Looking at it on this side would be the bed chain, which I did 3D print. However, you know what I did with it? There is a, there it is. There's an aluminum version that's in the kit. So I 3D printed one, but there's a aluminum version. And as much as I like my 3D printed one for color, I'm going to use this because it should guarantee me that everything lines up nice. Good. So we're going to need M3 by 10, M3 by 8, M2 by 10, and we're just going to go through and try and figure out, do I need a button head or what? So here it looks like on this printed or metal part, I'm going to need socket head cap screws. Socket head, socket head, socket head. And 2 by 10, that will be the ones that we use for the in-stop. A couple of M3 T-nuts. I'm going to get that. M3 stuff. So we need M3 by 10 socket head. Four of those. 4 of those. M3 by 8, which once again looks like a socket head versus a button head. Ah, 3 by 8 button. Nope, there's an M3 by 8 socket head. 2 by 10. That's going to be that other weird package. M3 by 40. M3 by 40s that I have are countersunk, and those are going to be to mount the bed. We're either going for an M3 by 35 or we'll see what was in this mixed bag of extras that they tossed. No Murph, but maybe Murph. It'd be really cool to get this. Think that that's going to be a next year thing rather than this year. 2 by 30s. Like, I really don't know if they've changed some sizes due to the metal kit, or I don't know. 3 by the whole thing of M3 by 10 button heads. How's it going, hybrid? Hopefully you're doing well. We're looking for screws. It says M2 by 10, but I'm not finding M2 by 10s. Three by 6s. We're just combining a few bags right here to make it easier on me later on when I'm looking for screws in this sundry bag that was added. Because right now I am not seeing M2 by 10s. Not in there. Might have to pull some M2x10s out of my own tile. Of course, they're showing what looks like, oh, whatchamacallit. They're showing things in there that look like self-tapping screws, but they're not going to be self-tapping screws because we're going into a metal piece. So I think I'm going to be done trying to dig through those. These are more stuff. Whoop, 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 whoop. Hey, there's some M2 screws, finally. We do have some 2 and 2.5 stuff in there. Sweet. M4 hammer nuts even. Okay. There's the M2s that we're going to need. 3x8. So a few extra things here. Toss those back in the bag and we'll worry about figuring those out later. We'll keep going. All right, so we found some things. That's always. So I have a lot of you. Well, thank you guys for hanging out with me. Okay, so our metal part we're going to put in with what looks like M3x10 into the aluminum piece here. So once again, we'll do a little bit of our Loctite as we put these in. I mean, it's a cable chain. It should not be an issue, but better safe than sorry. Definitely can't hurt, so. And quite honestly, with these, I mean, we could probably real easily get away with M3x8s based on how thin this bracket is and how thick the other piece is. I think 10s are probably overkill. All right, so that's on there. We will add a cable chain at some point. On the other side, we're going to need a bracket. Now I've got two different brackets in here. Trying to figure out which is which. Pretty sure it's going to be this one because it'll line up pretty darn closely with our bracket. And of course, we'll have an end stop that will mount to it. That end stop's going to have, I don't know, some wires probably attached to it at some point. So it's going to have to be mounted to the frame before we do anything else. And I'm going to have to drop this down. There's going to be two going to foul out on the part there. This once again is going to go in with a M3x8. And once again, this gets mounted in there and just follows the same curvature of the other part. Very hard not to have it twist on you as you're trying to get stuff there. Oh, 2x10. You mount the end stop to it, which, like I said, we'll mount it right now and we'll wind up probably having to take it off to do our soldering a little bit later. All three of them have the levers on them, so we'll leave the lever on there. And be careful, you do not want to over tighten these and basically squish your end stop. It would be bad. Just snug it and you'll be good. Go. End stop's going to be there. We're going to put a large nut or a large bolt with a nut on it so that we can then adjust the end stop right there. That would be the other screw that it's telling us to find, which is a M3x40, which I have still yet to find an M3x40. And you know what? What do I got? Do I have an M3x40 in here? See if I got an M3x40 in the other bench stock. M3x40. Good, I got one. We need an M3x40 and an M3 nut. And like I said, that nut's going to act as our lock nut. So once we get our Z offset set, we will tighten the nut against the bed plate itself. That will trigger our end stop. Pretty simple mechanism. Works really, really well. We'll fully adjust this later on. But it just tripped it. Go. Sorry about that. Habitus, is there a benefit to having the part move in the Z-axis compared to the gantry moving and the part staying stationary? It's 6 one half dozen the other. So very similar type of Z mechanism, right? Thick rod with a lead screw on each side is what the Ender 5 Plus uses for the bed system. And it was rock solid. And I do mean rock solid. I moved it to and once again, the bed goes up and down. Worked perfectly well. This setup works perfectly well. I have a similar type setup on my Bugaboo. I've got it dialed in. I've moved it around the house, picked it up, put it down, had it sit in the corner for 6 months, put it on the table, plug it in, and it prints. And I didn't have to touch the bed level at all. It just, boom, it works. So, I've got Boron 2.4s. I have Tridents. They both work really well. I love them both. It's, I don't know. So with the bed moving, then that means your gantry is fixed, right? Which means you can get quicker speed here, and you don't care about the speed in your Z-hop as much because this is relatively easy to do, right? You're talking 0.2 millimeters at most. This lets you get lighter in your gantry. When you do a flying gantry like a 2.4, you're having to lift that entire gantry and as you're trying to move things around. Exactly. I've got a Rook 2020 downstairs printing cars out all the time. I take a Rook. I've had my Rook 2020 to Murph, 3D Printopia, and Rocky Mountain. I'm getting ready to rebuild. I may rebuild it, or I may tear it apart and build it as a Rook 2020 Mark II, because tugboat 3D printing, I've got one more part to print, and I need to cut a frame for them. And the bomb is over at KB3D right now to send the bomb parts to them, and they're going to build a Rook 2020 Mark II. So yeah. All right, so this is telling us how we're going to put things together, and then it goes through and tells us how to put things together. I need to use the Z chain, which there's only a single chain in there, so I'm assuming that's going to be my Z chain. Seeing as how that feels like it can go in either way. Bottom this. We're going to come through here, and this is where we're going to use our M3s. I think we're going to go this way. I think that's how we're going to go, is go this way. Because it screws the chain using M3 screws and nuts. We won't need the nuts because we're going to be going into threaded metal part. Hey, Big Jano, how's it going? Let me take a quick look at the CAD. Awesomely not show a V-chain mount. That's great. I mean, it shows the mount, but it doesn't show like the Z chain or the bottom. So here's the mount, right, with the 2 screws. No Z-chain showing here, nor is it showing the lower mount, how it mounts. You would think they would actually include. That's awesome. So does it show that part? Entry. Here's back up here to the bed. Sorry for the desk roll. That's awesome. It stop. So that's great. So it tells me to install this, but it doesn't tell me anything about the lower mount. That's awesome. Have to go this way, mount in that way, but I'm not sure, like, assuming there would be a printed part over here, or maybe that's going to be fun. So how's it going, Jana? Uh-oh. A few more. Lurking, you spilled your stuff? Keep spilling all your stuff. Whoops. Gotta go this way. Need to use my ball end driver so I can get into it. Really don't know why I'm going to even bother mounting this. That, and I'm pretty do this the righteous. Need to mount the actual chain piece. This comes apart. Pop the chain loose. There we go. We'll just mount this. Be significantly easier. Once again, these could be a lot shorter. Because there's, like, this could be an M3 by 8 easily. Because once again, you're mounting through metal with screw holes, so it's not like you need to put a nut on the back. It would work great if you needed to put the nut on the back to hold it apart. Hey, Killer Dragon, how's it going? Welcome on in. Thanks, Big Jano. Let me switch back over here to our full browser window. Like I said, I just find it interesting that the CAD does not actually show the cable chain in it, so it doesn't show you how it mounts at the bottom end or anything. I think it turned off group. I don't know. I'll figure that out at some point. So we're back over here. This is the bottom of the instructions. However, we need to go back up because the next step is the gantry and installing the motors. And so I'm going to, quote unquote, desk scroll up. So there is how everything is set up on the gantry. We do have an all-wheel drive version. Motor mounts and integrated front hinges. This is kind of interesting in the way it mounts. Yeah, just really interesting in the way that those motors mount. So we need a bunch of parts. And here's the issue with those bunches of parts. We turn this around towards the front. And the bunches of parts that we need there, this here, we'll go there. Front motor mount. Front motor mount. Here's all the parts. That's the front motor mount. All the red parts are the PLA parts they provide with the kit. So we basically have to disassemble it, install it using our printed parts, and then mount everything back up here. So I just flipped everything around. The front of the printer is facing me. So I am sorry, folks. I apologize so much. I know that is probably loud. I do apologize. So we're going to take this apart. Then we will put this back together one step at a time based on what they tell us. There we go. There's that one whole top part. And this is the lower motor mount. And there's nothing else that we need to take off of that. We're going to leave that right there. And we'll see what we do to put this thing in there and build it. So we need to load some screws in there. So I'm going to take these screws out to get this piece out so that I can pop all of the nuts out of here and then reload it. Be a 2mm screw. Millimeter screw. And looking at this, there's probably ones on the other side as well. I am like dropping printed parts everywhere. Good thing that I don't need that printed part, but oh, I'll find it later. Take these two out as well. Okay. Two of the nuts popped out, two didn't. That'll make it great. Now we get to try and fish some of our nuts out. I know that sounded interesting. quite honestly, if I've got to break this part to get these out, I will. Might be able to get in there with my tweezers. There we go. Another one. Other one. There. Oh. So we've got the 4 M3s out. M4, there we go. Just came out. So we're going to grab one of our other parts. Get the one that matches. M4 nut down in the middle. We need our M3 nuts on these side passages here. Make sure to get any or crud out. Need grab my drills because I need to just clean the holes out. What we've got is some like support, like built-in support material, like the one layer that helps the holes. So I just need to run my drill through there to clean stuff out. I'm going to do it by hand so I don't cause any major problems. Here we go. So we're putting in 4 M3 nuts in these holes and then the M4 nut through here. The M4 nut is going to be what we use to tension the motor belts with. So make sure that all of those are lining up. M4 in as well. Got that. Attach the stepper motor to the bottom of the motor plate with 2 M6 6mm M3 screws. That is already done. Did they happen to Loctite those? No, and they were not even snugged. So we will solve that problem. So it's good to use Loctite on these because there's no plastic that they're going through. It's just straight through into metal. So we can use Loctite here, but on our other screws that are going to go through some plastic spacers, we don't want to use any Loctite. That's why I'm putting these here. Make sure that these motors stay nice and good. You're out feeling drained. Okay. Well, take care, Evil Diesel. And we will definitely see you on Sunday. Well, oh, wait. Maybe not. Sunday is kind of, I don't know, one of them important days, huh? Like, I think somebody keeps telling me that's an important day at least. So we've got our motor mount. It's going to mount in that direction. So these two screws are going to go into the bottom. Loosen that one up. And this is going to go in from the underside. Like that. And through the standoff and middle plate using 10mm countersunk M3 and attach it to the frame using one 12mm M4 and 8mm countersink. Lock the standoff in place using the 40mm M4 and the printed hammer nut installed during frame assembly. That just hurt my head. I think I understand what they're talking about, but okay, so I need to tighten this up underneath. And that one's way too long. Screw the standoff to the middle plate using the millimeter countersunk 3. Attach it to the frame using one. All right, let me go ahead and attach the standoff to the frame. We're going to do that using the countersunk screws here. Get that in there. Of course, that's just kind of freewheeling in there. Put a wet, whoops. We get a screwdriver in there as a wedge. That tightened up. Okay. That's like that. This is just way the hell too long. That's bottomed out, and this isn't even. So we've got the standoff mounted to the plate with the two 10mm countersunk. Attach it to the frame using a 12mm M4 and the 8mm countersunk M4 screw. Lock the standoff in place using 40mm with 40mm M4 with printed hammer nut that was installed during the frame assembly. There was no printed hammer nut that was installed during the assembly. I need to see if this pre-installed screw is actually a 12mm or if it's larger. because it seems like it's too long. It's 12 millimeter, got a fender washer. So 12 millimeter with a washer. 12 millimeter with a washer here, 8 millimeter over here. Doesn't tighten up. Ah, that's why it's not going to tighten up. I gotcha. I gotcha. I'm going to stop being an idiot. The reason it's not tightening up is because there's that sliding plate that is supposed to be up underneath it. So it's really not meant to tighten up. Let me get all my screws back in there that I keep dropping out. That would be the issue. So really, there's that. I'm going to need the M3 by 40 that comes through the side. Because there's a lock the standoff in place using M3 by 40 millimeter M4 and the printed hammer nut that is installed during the frame assembly. And that's a piece that I missed. So we're going to be putting in a standard M4 T-nut. We're going to have to get that lined up appropriately. I don't believe there was anything in there, so here's the M4. I'll go ahead and grab another one for the other side. And I need an M4, 40 millimeter M4. Ah. Okay. So this is going to go all the way through the standoff and into a M40 T-nut that's going to be in this front rail here. What I need to do is kind of get these laid in there and figure out where that T-nut goes and push it up or down to line up. This is going to pull it snug across into the front of the frame. That goes there. We're going to tighten up the M4 by 8. Appropriate size driver. We got that. We need the M4 T-nut put in and slid down. there. Grab the M4x40 socket head screw. So goes all the way through the frame into the T-nut and pulls the front edge nice tight against the. There we go. There we go. We figured it out. Or most of it. Now next up, we'll attach top frame. So this frame still has our T-nuts in it. This is going to line up in our channel. And the top of our printed part, we're going to use our M3x12s. Going to get interesting. These screwed in. Continuing to twist of its own accord, so we'll have to use a screwdriver on that again. Nicely. Here we go. Now we need to lock these in. Use the appropriate size ball and screw, and that will work. Hey, Bexy Beads, welcome back in. So now that is tightened in there. Okay, now we're going to have our two spacers. Insert the final standoff and insert the M35x3. Slide in the motor with its plate and tighten the M3 screw finger tight. Okay. Goes in there like that. We'll have our printed parts, and I believe this one goes, the thicker one here goes in on the far side. What happens? You drop the bolt out, came out of the hammerhead T-nut. I have a facetious question because you hope like hell that T-nut is still in place. You can thread back into it, because if not, taking things back apart is good. Okay, so we've got the one lined up there. I'm going to slide this in, and we're going to put the one screw in. Again, we need to put that in place. This forward. It between said screw and its washer. There we go. Need the M5 or M3 by 35 that goes all the way down through that spacer, lines up. Tighten that. And we'll grab the other spacer. We'll only align one way. Slide this spacer in. Line up the other screw and slide it down there. Screw that one down. Okay. And everything's at its outer reach. You'll loosen up this screw. You'll loosen these up slightly. You'll screw on the front, and that'll tension your belts. So it's obviously something you're going to do before you put panels on. But slightly painful. Toss those red parts away because we don't need them. But we have figured out the process. So that's good. I've figured out the process. So how you doing, Bexy? Isn't it kind of late your time? I'm just throwing out there because I don't want to be responsible if you turn into a pumpkin. It would be very bad if I'm responsible for a Disney princess turning into a up late. Okay. Millimeter driver. We'll take long screws out. It's 2:30 a.m. Yeah, that's kind of my point. We take the long screws out, remove our little plastic printed pieces and those away. We've got another 2 screws on the top here that we'll take off. The 2 button heads that go at the top. You wear tons of makeup to pretend otherwise. Uh-huh. Okay. Top plate's now off. Other printed part. Slide that out. We'll take these screws out. These will be the countersunk ones. And then we've got to fish our nuts out. No comments from the peanut gallery on that. Because like I said, I'm not going to be using these red plastic parts. So if I have to get these out, I will break the part. Don't care. But I think I just got them all out. So that part can go in the garbage. And this is the part we're going to need. Let's clear out any of the holes. What's the peanut gallery? Oh, those are just people that are making comments and, you know, snide remarks just to give me a hard time. I do love when you miss out on things like that, though, Bexy. Okay. Those are cleaned up. Now, screw in the M4 set screw with the bottom tensioner. The M4 nut would be pressed into the tensioning knob. Tensioner plate will be installed when the enclosure panels are on the printer. So then why would I? Yeah, so on these things, this hinge and this other bracket right here that goes on the front side of that motor, we need to wait because that goes, there's a panel that gets sandwiched between this and the motor, I believe. And then this tensioning knob will go through. So this piece is going to mount basically right there. This piece will mount right here. There will be two screws that go into the frame. This screw goes into the M4 screw and the spacer. And then there's going to be a tensioner that goes through here that will push on the motor. And that's how we're going to tension the belts. So screw in the M4 set screw into the bottom M4 nut pressed into the tensioner knob. Tensioner plate, this, can be installed when the enclosure panels are on the print. So we're going to hold off on this and the tensioner knobs, especially since I'm not sure if I printed those. Those could be these, or these I thought were the bed ones. We'll hold off on installing those. And we basically need to do the same thing for the other side, even though it didn't tell us that. So bottom plate, top plate, bottom plate goes in. He's lined up. Bottom plate goes in. Only the rear one gets inserted. Apparently used the right size driver and it works out a lot better. Okay, that's there. Need to get our nuts installed here. All like that. We're going to come up from the bottom with our M3x8 countersunk screws. Oh, I dropped a nut. I dropped a nut, folks. I dropped a nut. Dropped a nut and I have no idea where it went. So I'll find it when the vacuum finds it. Because I have plenty of M3 nuts. So I can backfill that one. Get this installed. Okay, spacers installed. We need to line up the M4 T-nut here. Go. We need the other M40 screw, or M440 screw. Oh, that's awesome. So out of the blue, there's just two random M40s with socket heads on them. Everything else is button heads. So I'm assuming that my socket heads are the ones that go in here, since that looks to be about the right size. That in nice and tight. Pop that other M3 nut in. But we need to install our top plate. Do M3 screws. People say snide things to you. Shall I slap them with my glass slipper? Oh, most definitely, Bexy. Most definitely. Up one here. We're going to screw these down. One. Lacey sends those of us that he does not share his peanuts with. Hey Bob, how's it going? Feel like that. Drop a second one. They normally land close to the same spot. No kidding. Yeah, I think it may have hit and went up underneath my table, in which case it's there till I move the bench again. Okay, so we got those. We need our spacers again. One goes over here in the back. a little bit longer. Efficiently lined up. The other one goes right here, and it's just a matter of getting it in the right position. That. Bring this in. We need to kind of get our pulley in, and then flip this side around, make sure we're up underneath the other screw there. We're in. Put in our long M3 screws. Work with me, not against. One. Other. Driver. There we go. Okay. Put the drill back up. Close this, get him out of the way before I knock him over. Okay, folks. Where are we at? We got the front stuff put in place. Got a motor cable that we'll put right there. Tweezers go over there. What's up next? Cold coffee. No, that's you're not on your best form, tired, in pain, and fed up, but you can't sleep. It's just like a loop you're stuck in. That's not good. Dishwasher wants to wait up and see the northern lights, so you're stuck staying up too. I understand that. Okay, so we've got the left and the right side done. Now it's the secondary motors or idlers, the all-wheel drive. And that's going to go along the back side of the printer. So we'll take the printer and we'll flip it around like this. Okay. And there's various spacers that we need to undo or install. So let's see how we want to do that, because here is our fully put together rear frame, but you can see there's a printed part here. There's a little spacer between each one of the rollers in here. So we need to take a couple of things off. And unfortunately, it looks like we're going to have to take this whole thing apart and then kind of do like we did before, is take things apart and then mount it back together. And I would really, really, really like not have to take some of this. Because I'm hoping the rear spacing is good. So I'm just going to take the top plates off, preferably. Because these are the bolts that I need to replace printed parts on anyhow. So there's a nice shoulder bolt. That's pretty neat design right there. Now, floppy. And let's take this space out, and as soon as we do, the whole top comes off, which is what I want. Here we go. There's that. There's a spacer. There's a gem, right, or a pulley and a spacer, which means was there a gem stuck right there for that pulley. So this side is done. Now we're going to do the same thing over on this side. And what we'll be able to do is take the top plate off and mount the bottom plates directly on, hopefully. And we're just going to replace these with our printed parts. Bolts, 3-bolt. Bearing. Okay. So my hope is that I can take this whole bottom piece as it stands and mount it up and lock it in. Here's to hoping that their spacing was on the money. Built the gantry. You can get full whenever you want. There we go. Side in. Other side. This would probably be easier if I flip this whole thing over, huh? How about we do that? Flip that over. Take this and flip this over. Hope is that these would just line up. I mean, no, I'm pretty sure I'm on crack that happened, but one can hope and pray. Dang. A bit wider, and I am feeling a little bit of an indent on this side. So that frame moved over. This now dropped down. Up, 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 up. Boom. Boom, yeah. Okay, so now go in and here we're fully back and flush. Tighten that first front one there. Thought we were there. Are we not? Oh, we are. We're. There we go. Can't be too nice or she'd think you did something wrong. I understand you there. I understand you there. One thing I want to do before I go too much further is just try and trying to make sure that these things did twist. Yep, that twisted. That one did not. That's the problem with hammer nuts is sometimes they twist, sometimes they only twist partially, sometimes they don't really twist at all. And it's annoying. But normally if you can get one of the two, then you can loosen the other up and redo it and it'll catch. Okay. So the back motors and the arm are in. Now we just need to build things back up based on the instruction. So this side, kind of building it from behind, we're going to need one of our spacers for the M3 side. Okay. And then so this is spacer. Pulley. Spacer, pulley, and then a shim. Top of the oofta. That almost. That I can live. Spacer shim pulley. The other side is shim tooth pulley spacer. So there's the shim, the tooth pulley, then the aluminum spacer. Put our plastic piece back in there. And then our top motor mount comes on. Everything in. Seriously? Okay. Now I'm going to take the shoulder bolt. Get down there. Their shoulder bolt. Down there. That shoulder bolt is lined up. This shoulder bolt's lining up. I'm not tightening them down just yet. I'm going to get my spacer lined up there as well. M3 gets pushed through everything. All right, that's lined up and tightened down. I'm going to go ahead and tighten down my plate. Hey, Hobby Main, welcome on in. Hey, Mayhem, how's it going? Hope you're doing well. Sorry if I wasn't paying attention. I'm trying to take apart the gantry and reinstall it as gently as possible without, like having to redo a whole lot of pain. So you're like trying to stack up shoulder bolts and things like that without, or making sure you get them in the right order based on the sides. So this side, the tooth pulley is, the tooth pulley's in the front, the smooth pulley's in the rear. And I love it. It shows how to do one side and that's it. So the other side should be the opposite, which means my tooth pulley is going to be the higher one and it should be in the front. So this one is the smaller one, which means I need, yeah. All right. Darn it. CAD. That's what CAD's for, right? Rear motor, left side. Smooth pulley is low over here. Smooth pulley is high over here. Means spacer, and then my smooth pulley with the shim on top. And then the other side goes shim. Smooth pulley. Spacer. Dude, this is like a game of operation. This will sit down. Nut came off. Nut back on there. Nuts there. Shoulder bolts go through. Okay. Go ahead and tighten our shoulder bolt down. Not going to tighten it all the way. I just want to make sure it's engaging so that we start getting our alignment. Nice. Need my other spacer up front here for my M3. Okay. You sent me 2 messages on Discord? Okay. Do I need to look at them now, Killer Dragon? Or is it something I can look at after the stream? You were, yeah, I was in the zone. I have been in the zone trying to make sure that these are good to go. All those are going well. These are moving without rubbing. Left side I looked at. Let me check the other side. So this side, the pulley should, the tooth pulley is high. Pulley is high, smooth pulley is. So these pulleys are correct. These pulleys are incorrect. So I get to take this one apart. I need to swap the 2 pulleys. Yeah, like I said, Killer Dragon, is it something I need to look at the moment, or is it something I can get to it after the stream? Hey, Pez, yeah, I'm still going. I'm still going, and I mounted these 2 pulley stacks in the reverse order. So I got to take this apart. Swap my pulley stack. Yep, yay, it's Pez. Okay, so see if I can gently not send things flying around. That goes there. Here. Damn it. Again. So this goes here, but this pulley goes here. This pulley goes here. I'm on top. Dude, this is like playing Operation as a one stack and push the other stack completely off to the side. Awesome. Okay. I'm sorry if I'm not paying attention, but I'm trying desperately to get this stuff lined up. Did join my Discord, by the way. Sorry, I forgot to tell you. No worries. I will check your messages after the stream, unless you tell me that there's something that I need to look at now, in which case I'll look at it now. But if it can wait till after the stream, I will check it after the stream. Yeah, thanks, Pez. Pez knows me. I get ingrained on these tasks, and if it's not related to this particular task, I will most likely look at it right after the stream and respond. If it's something I need to look at because I'm doing something wrong on this build, please, by all means, let me know. Something that's time urgent, let me know and I'll take a look. So I'm just kind of snugging these up to get them good. And then I'm going to lock in my frame bits. Oh, okay, cool. And by the way, everybody, I have, sorry, you're gonna get some in my head there. I have recently uploaded all of the outstanding VODs to YouTube. So all the VODs should be posted out on YouTube now. Okay, so tooth is high and smooth is low on this side, and the other side, tooth is low, smooth is high. That's right. Okay. Whew. Awesome. Yeah, okay. I was like, what is wrong with that? This is the two-wheel drive versus. I was about to freak out there, folks. Don't see me freak out. So it has a motor there. That shows There must be. We're good, I believe. Okay. So our gantry's in place, front, back. We've got our Z-axis fully in place. Five, 2, 1.5. Get that over there. Flip this back around. Well, we'll flip this around so you're looking at it from the front. Tape is the front. So front motors, rear motors. Yeah. Bed is offset towards the front of the printer, which gives us room in the back to do things. Also, our electronics panel is going to be in the back of the printer. What else? Gantry's assembled. Z-axis is assembled. Dig through here. We would have the VzBot tool head. That is, believe it or not, yet another manual. There's a separate manual for the tool head. So, okay, Build Over Bot, have a great night. We're actually going to get ready to be done here. I'm sure Mrs. Dragon is about ready to chomp at the bit for me being on here. But looking at the way our motors mount, there's nothing that I can do to support these brackets. They are literally supported by the motor mounts. So that's good. We can remove these stoppers now because our gantry is not going to go anywhere. Next up, I'm assuming we'll be putting in our X carriage. It talks about the print head. Okay, and the Y gantry and rail idlers. You know what? Let me see real fast if I can get the gantry back in there. Because once again, it's our carbon fiber tube. I printed the parts that go into the end to enable us to have our friction fit. So provided that I can get this in there, and if I can't, then I just need to do a little bit of filing. Just need to file a little bit of edges here. Maybe we'll go ahead and install our gantry while we're at it. Because I got it out while it was assembled. I should be able to put it back in while everything's assembled. There's literally 2 screws completely through this printed part, which is acting as a like crush preventative system. A pretty doggone tight fit. There we go. He's going just a shade more for them holes there to line up. one of those things of you need to go in a little bit more, but definitely not too much. Flipped on my phone. I was like, what happened? All right, so maybe not. Maybe we'll have to do that tomorrow because I'm going to have to work on the fit and finish here. Get this to go in nicely. But yeah, folks, we're going to go ahead and call it a day for today. And I say tomorrow, but tomorrow is Saturday, which means it's Black Box Day. And it may be a very short day again because I'm getting kind of family wants us to come out and spend time with them for Mother's Day and all that stuff. So we're probably going to have to go out and visit the family because we've got everybody meeting from both sides. So we should probably go and play nice. So you too, Pez. So does anybody have a good raid target for this evening? Is there anybody else streaming tonight? Yeah, I'm pretty sure Zombie Hedgehog is. Oh, you're welcome, Bexy. Thank you for coming and hanging out. I hope it was fun. Please get some sleep. Declarations is on. Okay. We can do that. That one slipped in a little bit easier. I think the other side. Should have. I should have sanded the side edges a little bit on that. Because that's a pretty tight fit right there. We'll have to work on that. And I will do that off stream. So, okay, everybody. Once again, thank you guys for being here. Hey, Tracy V, how are you doing? We've been working on our VZ 250 or 250, our VzBot 235 build. Sleep never heard of her. Exactly, Bexy. That's what she said. I'm trying to push my little piece into the end here. This one is pretty well lined up with the holes, maybe a tad bit too far. This one's super tight right now. And I'm hoping that I didn't get myself stuck into the point where I went, it's too tight and I'm not going to be able to get it to move in or out. Because that would be bad. One side's lined up really good. The other side is not. You got to be careful that you don't damage your carbon fiber tube, or you go and you order a new carbon fiber tube. But this will mount between the two Y-Gantry rails, just like so. Okay, just like so, but yeah, just like so. And we'll get them lined up, we'll get them installed, and then we will be ready to keep going on the next stream. So with that, Everybody have a great night. I'm going to go ahead and get a raid going to declarations. Go find him. I'm following him. Go. Declarations. Go ahead and get the raid started. Thank you everybody for coming and joining me this evening on an impromptu stream. We kind of got things back going where we were trying to get to last night. So thank you all very much. And I will see you guys tomorrow. Like I said, it's probably going to be a short stream so we can still make it out. We got about an hour drive to go out and see everybody. We may do another short stream like we did last week. Just wanted to give you guys some more time with me. And we will see you guys tomorrow. Go ahead. Thanks for following me over to declaration. Good night, all.